Hello and good afternoon, everyone. My name is Muhammad Akmal Ikhwan bin Zainal Abidin with metric number of 215676. I will be presenting my final year project under the supervision of Associate Professor Dr. Wan Zuhaini Sa'ad paired with Ahmad Firdaus Ezani, titled Characterization of Aspergillus fumigatus RC based pectinase, Stability, Storage Conditions, and Shelf Life for Agricultural Applications. Before I continue with my project, I will introduce a bit about pectinase. Pectinase is a group of enzymes that break down pectin, a complex polysaccharide found in cell walls of plants. Pectinase enzymes belong to the hydrolase family and include different types such as polygalacturonase, pectinesterase, and pectin lyase, which act through various mechanisms like hydrolysis, deesterification, or trans-elimination. These enzymes naturally occur in fungi, bacteria, yeast, and plants with microbial sources like Aspergillus species commonly used for commercial production. Pectinase enzymes are widely used in agriculture, especially for processes like fruit juice clarification, fruit ripening, and plant fiber wetting. However, one major challenge is maintaining the enzyme activity during storage and exportation. So let's look into the problem statement of my project. The first one is the stability of Aspergillus fumigatus R6 based pectinase is significantly affected by various storage conditions which limit its shelf life. Secondly, the lack of packaging strategies that maintain the enzyme activity and extend shelf life. To address this issue, my project has two main objectives, which are to evaluate the effects of storage parameters on stability and activity of Aspergillus fumigatus R6-based pectinase, and secondly, to develop packaging conditions that maximize the shelf life and maintain optimal activity of the pectinase. Through this research, I expect to identify the optimal storage condition that maintain more than 80% pectinase activity after 60 days and develop a suitable packaging materials that enhance enzyme stability. So here's our plan to achieve this objective. The first one, I will produce a pectinase from Aspergillus fumigatus RC using solid-state fermentation. Solid-state fermentation involves growth on solid substrate with minimal free water, which mimic the natural habitat of fungi like Aspergillus fumigatus. Besides that, a study by Wong et al. States that this method of fermentation enables higher titer of enzyme production, low risk of contamination, and lowering operating expenses. Next, I will store enzyme samples under different conditions, which are at various temperatures, such as -20 degrees Celsius, 4 degrees Celsius, 25 degrees Celsius, 30 degrees Celsius, 35 degrees Celsius, 40 degrees Celsius, and lastly 60 degrees Celsius. Such that I will also store this pectinase in a different humidity level, different light exposure, and in different container types, such as amber glass vials, clear glass vials, and Elkin tubes. Then, I will measure the residual enzyme activity using DNS method to quantify the amount of reducing sugars released from the pectin substrate. Finally, I will analyze the data to determine which storage condition best preserve enzyme activity and provide recommendations for practical storage and exportation. In this part, I will calculate the mean residual activity and standard deviation for each condition to ensure reliability of the outcome. I will also use ANOVA to determine the differences in enzyme activity between storage condition, and I will calculate the half-life of the enzyme under each condition. I believe this finding will contribute valuable knowledge for the commercialization and effective use of microbial enzyme in agriculture. That's all from me. Thank you.